threshold because maybe I think this is because of the effect of filter generation, and so these are the results. As you can see, all the models seem to converge to a certain degrees, and it's because of the effectiveness of generating convolution filters.
What about the filter, the hashing? Did you do any analysis like on how much time that saved?
Using hashing tech, yeah.
Right, it's computationally it saved a lot of time, right?
I think this graph can be the answers. And using hashing, we can save about half the time compared to the full generation technique.
Any other questions? Okay. Let's thank our speaker again. All right, our next talk is Zero-Shot Cross-Lingual Opinion Target Extraction by Soufan Jabara.
This laptop?
That's for the remote. Just put it on it.
Okay, hi. Thanks that you all came to my talk. I'm presenting the paper Zero-Shot Cross-Lingual Opinion Target Extraction. I'm Sofian Jabara, and I work at Semalytics. We are a text analysis company in the pharmaceutical domain. And my supervisor in the University of Bielefeld is Philipp Zimiano. All right, so my work is part of the bigger area of aspect-based sentiment analysis. And we are, so what we want to do is, in general, we want to find out what a user or what an author expresses his opinion about in a text. So we have a sentence here, those rolls were big but not good, and sashimi wasn't fresh. So we can see that we have two targets in here. Those are the rolls and the sashimi, and there were opinions expressed towards that. And in fact, we see that there's a neutral opinion towards the rolls because they were big. This can be positive, can be neutral. But there's also a negative expression here because they were not good, and also the sashimi were not good. And we are focusing on the extraction of the targets here, so the blue boxes. And this can be sometimes difficult because they are not always only single words, but they can be really long phrases like, I fell in love with the egg noodles and the beef broth with shrimp, dumplings, and slices of barbecue roast pork. So this is the entire phrase that we want to detect here. And sometimes they're really specific, so they can contain really domain-specific terms like, I like these samosas, chai, and chole, but the dosas and dal were kind of disappointing. So you see that you see what kind of problem that is. We can, of course, when we want to solve that, we can address it with a sequence tagging approach. So that means we need some kind of supervised model here, and usually you do something like this. So you have your sentence at the bottom, and you tokenize it, you put it through your sequence tagging model, and you produce an output sequence at the top. And for that, obviously, you need some kind of training data. But generating this kind of training data can be really costly because you have a lot of annotation effort, especially if you want to apply that for several domains or several languages. And in this work, we are focused on the latter part. So how can we actually reduce the annotation effort here for transferring a model to new languages? So what we want to do is zero-shot and cross-lingual opinion target extraction. So it would be cool if we can train a model on the English data that we have. And with some kind of machine learning magic, we want to infer models for other languages like Turkish or Russian or Dutch that can actually also perform the same thing on that particular language. And while we're at it, maybe it's also possible to combine the resources of several languages and improve the results for all of these models. So this is our goal here. And that type of magic already exists, luckily. So it's called multilingual word embeddings. And so in general, when we have word embeddings, if we plot them for different languages in the same plot, we get something like this. So we have the vectors for the word cooking and passenger in 3 languages, for English, for Italian, and for German. And you see that they don't really align here. So we need some kind of alignment so that they align across languages and semantically similar words are also close together. So that they, in the end, yeah, you see like here that they're close together here. And there were some works in that regard. So what we are doing is we take the approach from Smith and colleagues from 2017 and from Lample and colleagues from 2018. And so we use their pre-trained multilingual word embeddings as they are. And we put them into our cross-lingual model here. So we start with a model that's purely trained on English data, but at the bottom we use the aligned English word embeddings. Then we apply some CNN layers on top, so that's our sequence tagging model, and in the end we have a softmax layer that classifies a tag per token. And now we train the whole thing, and we swap the embeddings. So we take the English embeddings and, for example, replace them with the Dutch embeddings. So now we have a model that is already pre-trained. So the lower part is the one that we switched out, and the upper parts are the ones that we pre-trained on English. And now it's actually capable of perform the same extraction on Dutch input. And of course, we want to know how good that performs. Does it even work, and how well? So the first thing we want to ask ourselves is, what is the performance on unseen languages? So if we train on one language and apply it on a completely unseen one. Second, we want to see if there's a benefit when we combine several languages in our training part and apply it then on an unseen language. And thirdly, how much annotation effort can we actually save when we annotate a few samples in our target language and add that to the available data for the other languages. And in our paper, we also have a fourth question about the impact of the alignment method, which we won't discuss in this presentation here. Okay, so for the evaluation, we use the aspect-based sentiment analysis dataset from Semival. They provide a lot of documents annotated in several domains and languages, but we restrict ourselves to the restaurant domain here. And so they have about 1,200 to 3,500 documents, and we use the data sets for the languages English, Spanish, Dutch, Russian, and Turkish. All right, so the first question was, how well does it perform when we train on one language and predict on another unseen language here? So that is the setting. And so on the right, you see a plot. It's empty right now, but the vertical axis shows the source language, so that's the language we train on. And the horizontal axis shows the target language. So that means that the diagonal here, that's the performance for a monolingual model that does no zero-shot prediction here. So we see that for English, when we train on English and test on it, we get about 66% of F-score for exact matches of these phrases that we want to extract. For Spanish, it's a bit higher, and you see the other scores as well. And now, the zero-shot performance for training on English and predicting on other languages, that would be the first row here. And when we have a look at that, we see that for Spanish, for example, we achieve about 50% F-score. And if you compare that to the 68% that we get for training a monolingual model, that's actually quite high. So it's 73% about that. And you see the same thing for Dutch, and Russian is also quite well, but for Turkish, the results are not that good. Yeah, we can have a look at that, why that might be later. And of course, we did that for the entire table here, so we trained on all language data that we have and tested that on all the others. And the observations that we can do here is that the absolute best scores that we get is for Spanish here in the zero-shot performance. And the best relative scores we get for Dutch, so we achieve about 77% of a relative performance compared to the monolingual baseline model. All right, the next question was, does it help if we train on more than one language and then do zero-shot performance on other languages? So here we have a plot, and at the bottom you see the target languages. And now, of course, we want to have a baseline again. So again, we have the monolingual performance here. Then we take the best language, the best source language for each of these target languages from the previous plot that we had. We plot them here. And now for each of those languages, we trained a model on all the other data. So we trained on everything we had except for the target language data. So we just threw everything in a pot and trained that model. And you can see that in almost all cases, we get quite a big improvement here. So these are always between 6 and 9% in F-score points. Except for Turkish again, here it seems to actually hurt the performance when we add the other languages here. Okay, and the final evaluation that I want to look at is the benefit. So usually you do have some annotation data in your target language, and now we want to see what the impact of that is. So how much data do we need to reach a good performance with our model? So what we did here is we trained on a source language, in this case English, and also a fraction of the target language annotation data here. So we added to all the English data that we had, we added 20 samples, 50, 100, and 200 of the Dutch data. And then we want to see how the scores develop here. And as you can see, the orange line is the model that is trained purely on the Dutch data. And you can see that you need at least 100 target samples before you can actually get a model that performs anything really. But if you combine that with the English training data that we assume that you already have, because English is a well-supported language here, you already have a system that performs quite well. And you see that you always have a higher performing model if you add the English data to your available Dutch data. And particularly, we can see that a model that's purely trained on Dutch data with 1,000 samples performs approximately as well as a model that only uses 200 samples. So we can basically save 800 annotation points by just using the English annotation data that we already have. Okay, and we did that for all the other languages as well. We always took English as the target language here, but you see that the trend here is actually the same for all. So you have a point where you need at least a couple of annotations before you can actually do something, but if you use your cross-lingual setting, it's working right from the start. Okay, so our conclusion here is for the zero-shot performance, we were able to achieve about 77% of relative performance to a model that's trained on to a monolingual model, and that we could do with a single source language. And if we actually add some other source language as well, we get about 87% of relative performance. And then, so a multilingual model that's using more than one language always saves annotation data. So it seems to be beneficial to always combine languages in the training process. And we also want to have a quick look at the future work that we came up with. So the model that we used is a CNN, so it has a limited context here, and there are more sophisticated models already out there for opinion target extraction. So it might be worth considering if our approach here actually translates to more complex models, or if that is only working for the CNN here. So the complexity of the model would be interesting to investigate in future work. And also, we saw that there are different performances regarding the source and the target language. Especially Turkish seemed to be problematic here. So we didn't get as good results as for the other language pairs. And we suspect that is maybe because Turkish is an agglutinative language, so they add a lot of suffixes to their words. And maybe that hurts the performance for the multilingual word embeddings that we use off the shelf. And then the languages in this small data set, they have different word orders. So I think English and Spanish, they have a kind of similar word order, but Russian and Turkish are really flexible in what they can express and in which order. So it would be interesting to see if the similarities between languages actually give a clue if they are also helpful in this pre-training or in this multilingual training process. Okay, any questions?
Thank you for the presentation. Just one question. So in the beginning, you said that you have evaluated your work mainly on restaurant reviews.
Yeah.
Have you explored like more domains which might be more diverse depending on the locale?
We didn't do that yet. So SemEval would offer a couple of domains in that regard for several languages, but we just picked the domain that has the most languages because we wanted to explore that aspect more.
Okay. Do you see any issues with this approach? For example, like if you put it on sports, where there might be like distinct set of sports being played in different locales, so the way of expressing opinion might be different?
That's a good question. So for the restaurant domain and the other domains that we looked at, usually you have noun phrases as the opinion target. So if I can imagine that if that is still the case, it would work to some regard, but not sure if, I mean, the domain will probably have an influence and would probably make sense to train on the same domain, but in a different language, but not switching both at once.
Thank you.
Thanks.
Hello, have you considered being a little bit more selective regarding which languages to start with? Like if you're coming up with a Dutch model, you'll be only using English plus German. If you want a Spanish model, then you use Italian plus French. Would this help in terms of, since Turkish is hurting, maybe that's another way to go?
Yeah, that's a really good idea. So we also thought about that. For example, I think the original data set also has French available, but we couldn't use it because the download script didn't seem to work anymore. So we would expect that Spanish and French would be a bit closer together and maybe the transfer would work better in that regard. And I think it would be interesting, as you said, to really look at the similarities between the languages and see if they actually translate to the performance that we gain here. Okay, thanks.
Hi, thanks a lot for the presentation, I liked it a lot. Just a couple of comments, more than questions. With respect to I've been reading the paper, you also compare with the state of the art, and I think it'd be nice if you could try your approach with one of the recent papers. I don't think I'm not sure about the names, Lian Lam maybe, but there is one there are a couple of papers that use joint features with polarity expressions.
Mm-hmm.
Yes, in order to improve results. So
Okay,
if you could
yeah.
get this kind of results without using those polarity expressions, that'll be nice, because you will need even less annotations.
Mm-hmm.
So they also use the opinion expressions from the
Yeah, I
texts.
think they used some lexicon to label them.
Yeah,
because they were not
there are two
available.
papers. One they annotated manually, and the other one they do it automatically. So
Okay, yeah.
I can give you references.
I think I know the paper. Yeah, that's an interesting one.
Yeah, it's very nice. I think also the thing about Turkish, I already work with that, and the problem is that it is too small, that data set. It's very, very, very small.
Okay.
Because Russian is also high inflected, so
Mm-hmm.
I'm not so sure about that being the actual problem with the transfer there.
Okay. Mm-hmm.
But it's my personal.
Yeah, thank you very much.
Cheers.
I'll look into that.
Okay, let's thank our speaker again.